All right, so we are going to go through multiplication of radicals. So here's the good news. We have been using the multiplication property of radicals during the last few sections. So this is really not new. The only thing that's going to be new is that we're upping it a level. We're going to do a little bit more complex types of multiplication. That's okay. All right. So let's say, for example, in this first example, that we are taking just one expression, one radical expression times another. Okay. So that's really what we have. 3 square roots of 7 times 2 square roots of 14. So we're going to go ahead and multiply the coefficients. 3 times 2. And we're going to go ahead and apply the multiplication property to the radicands. Okay, so the numbers underneath that radical sign. That's what we're going to do next. And that's how we get 7 times 14 underneath that radical sign. So that's going to give us 6 times, well, instead of multiplying 7 times 14, we know that 14 is really 7 times 2. So we've got 7, the original 7, and then that 14 broken down into the factors of 7 times 2. Well, that's going to allow us to work with that 7 squared. Bring out a 7, so now we have 6 times 7 root 2, or 42 root 2. Okay, that wasn't so hard. Now, what if we are looking at a binomial times a binomial, and within those terms inside of the binomials, we've got radicals? Doesn't matter. We're going to apply the distributive property just like we have in the past. Okay, so we go ahead and start with this 3 root 5. And then we first start by multiplying it by 7 root 2. That's where we get the 21 root 10. 7 times 3 is 21. 5 times 2 is 10. Then we take that 3 times root 5, multiply it times 5. And that's going to give, actually times negative 5. And so that gives us negative 15, because 3 times negative 5, negative 15 root 5. Now let's go ahead and we take this positive 4 and we multiply it times each of those terms in the binomial to get positive 28 root 2 minus 20. None of those are like terms. None of them are like radicals, so we can't simplify anything. That's just our answer, and that's okay. What if we had something that looked like this? So we've got root negative 2 times root negative 8. Okay. So you can't multiply Why? Because when I multiply 2 negatives, I get a positive. So I know that the root of negative 2 is not a real number. But if I take that negative times a negative, don't I get a positive 16? Doesn't work that way. Okay? You can't take something that's not a real number and multiply it times something that's not a real number. Okay? So you can't multiply these because they are not real numbers. That's why. Okay, so we don't even try. All right, let's go to some more examples. Let's look at the cube root of 4 times the cube root of 2. And so I can take my cube root, multiply 4 times 2, and so that's going to give me the cube root of 8. Well, I know that 8 is the same as 2 cubed. And if my exponent and my index match, then I can take out the cube root. And so I can simplify that to 2. Let's look at our next one. So I can take this cube root of 4 and multiply it times each of those terms inside of that binomial. So that's going to be the cube root of 4 times the cube root of 2 minus, I'm going to put the 3 in front, 3 cube root 4. Okay, so I just did the cube root of 4 times the cube root of 2. That's what I just did. Okay, so I know that this is going to simplify to 2. The cube root of 8, which is 2. Then it's minus 3 cube roots of 4. I can't do anything else. That is my answer. All right, let's go ahead and look at this next one, C. So this one is 2 binomials. So I'm going to start by taking the square root of 2 times the square root of 2. Anytime you multiply the same radical times itself, it's going to be equal to that radicand. When it's a square, I should add that, when it's a square root. So square root of 2 times square root of 2 is going to give me 2. All right. Actually, let me just go ahead and write these here, and then I'll simplify them underneath. Then I've got the square root of 2 times 5, so plus 5 square roots of 2. Now I'm going to go ahead and go underneath. So I've got negative 1 times square root of 2, so minus square root of 2. Negative 1 times 5 would be minus 5. All right, so we've got here square root of 2 times square root of 2, which would be square root of 4, which is 2, plus my middle terms can be combined. So that's 5 minus 1. So that's going to be 4 root 2 minus 5. I'm not done because I have those integers that I still need to work with. So this is going to give me, you can either write it with the negative 3 in front or the negative 3 following the radical. I'm going to put it in front, negative 3 plus 4 root 2. There we go. All right, for D, oh my gosh, I'm multiplying a binomial times a trinomial. You would think that would be so much harder. No, it's not. All right, so I've got the square root of 3 times negative 8 square root of 3. So that's going to be, well, here, I'll just write it. Negative 8 square root of 3 square root of 3. Okay, now I've got square root of 3 times square root of 5. So plus square root of 3 square root of 5. And then I've got plus square root of 3 square root of 2. Now let's use a different color. Let's do orange. And let's take negative root 5. So negative root 5 times negative 8 root 3. Now I've got negative root 5 times positive 5 root 5. Negative root 5 times positive root 5. Negative root 5 times positive root 2. Oof. Oh my gosh, we're falling off the page. So let's go ahead and simplify this baby. I'm just going to use black to simplify it. So right here with this very first term, square root of 3 times square root of 3 is 3. So negative 8 times 3 is negative 24. Plus square root of 3 times 5 is 15. Plus square root of 6. Now I've got, for the orange, negative root 5 times negative 8 root 3. Okay, so that will be plus, because a negative times a negative is a positive. A positive, my coefficient is an 8, root 15. Now I've got a root 5 times root 5. So that is 5. So minus 5. And then I've got root 5 times root 2. So that would be negative root 10. Well, I don't have a ton of stuff that can be brought together, but I got a little bit. So let's start with negative 24 and negative 5. So that's going to give me a negative 29. And then I've got my root 15s. So I have 1 here and 8 here. So that'll be plus 9 root 15. Then I've got my root 6. Then I've got my minus root 10. That whole thing, that's my answer. Okay. Let's go ahead and look at E. Oh, I love E. I'm like, whew, thank goodness. I'm tired of all this hard work. E is easy. Okay. Here's the first thing I want you to notice about E. The first term in each of those binomials is the same. The second term in each of those binomials is the same. The only difference is in the first one we have addition, in the second one we have subtraction. So these are what we refer to as conjugates. And we know with conjugates that when you have two binomials where your terms are different, but they have opposite signs. Okay, actually, I should say your terms are the same, but you have opposite signs. Then that is always going to equal the difference of two squares. So I kind of screwed that up the way I said that the first time. So let me say it again. Conjugates, your terms are the same. So if they both have an A, they both have a B. The only thing that's different are the signs. One's addition, one's subtraction. So that is always going to give you dots, the difference of two squares. All right. So how does that work with this problem? Okay. So that one, I'm going to take the square root of 5 squared minus the square root of 2 squared. And so because my exponent matches my index, that means I can pull out that radicand, which is 5. I do the same thing with the 2. 5 minus 2, that equals 3. Beautiful. All right. I have exactly the same thing going on with F. They are conjugates. So this is going to be a root 6 squared minus 5b squared. Okay. So I need to apply this exponent to both of the factors. So I need to raise both of those factors to the power of 2. So that is going to give me a squared, and then the square root of 6 squared is just 6. All right, minus 5 squared is 25. B raised to the power 2 is b squared. I'm just going to make this a little more comfortable. And with this first term, put my coefficient in front. So that'd be 6a squared minus 25b squared. There we go. All right. So let's go ahead and look at this concept, which is one that we've been using. So this is not new, but it's just formalized in this yellow box here. Okay, so basically what this is saying is, hello, when your exponent is equal to the index, then that is going to be equal when you simplify it to the radicand. That's all. Okay, so let's go ahead and look at these examples. So the fourth root of x to the fourth. That is going to be equal to x. The ninth root of x to the 9, there is a mistake on this. This is not equal to 9. It's equal to that radicand, x. And then this next one, we have to be a little careful. We have two factors here. 2 is a factor, and then the cube root of xyz is a factor. So both of those factors get raised to the third power. So I've got 8 raised to, or I'm sorry, 2 raised to the third power is 8. And then because my exponent is the same as my index, then that is going to give me xyz. So my simplified form is xyz. Whew. All right, let's go through these examples rather quickly here. So the square root of 5 raised to the second power, no problem. That's just 5. For B, let's be careful here. I need to raise both the 4 and the radical to the second power. So if this becomes 4 squared and then the square root of 8a squared. Okay? So 4 squared is 16. Then because my exponent and my index are the same, then I can, this is 16 is multiplied by 8a. So now I just go ahead and this becomes 128a. Let's look at C. Because the exponent and the index are the same, it's just when I simplify this, it's equal to that radicand, which is 150 x squared y. For D, I'm going to raise both the numerator and the denominator to the power of 2. So this becomes, let's say our fraction bar is right here. So this becomes the cube root of 7x, that whole thing, squared, and then y squared, which is not really super helpful to us. The only thing that we could do if you wanted to is you could rewrite it so that it's the cube root, and instead of putting this exponent on the outside, you could apply it to the 2 factors underneath that radical. And then the only thing you would want to do there is that 7 squared is then 49. That's the only thing you could do. All right, let's look at some special case products. All right, let me see so you can see that yellow box. So we have here a binomial squared. We've had that before, okay? And that will give you a perfect square trinomial. And that's what we have here with a minus b squared. We've got it again, a perfect square trinomial. Then we have conjugates, which is going to give you a difference of 2 squares. Okay, so if we have an example here where it's a binomial squared, okay, our a is 3 root 2. Our b is root 5. And I just mean the a and the b in terms of how we plug things in to into the variables here. So I'm going to take 3 root 2, raise it to the power of 2, plus 2, there's our 2, times that first factor, which is going to be 3 root 2, times my second factor, my b, would be root 5, plus root 5 squared. Okay, so now when I go through and simplify, I need to make sure that my 3 is raised to the second power. That gets me the 9. And the root 2 raised to the second power is just going to be 2. So 9 times 2. Next, I have 2 times 3. And then I can take root 2 times root 5. Okay? That's what we've got going on. And then root 5 raised to the second power is just 5. All right, so 9 times 2, that gives us 18. 6 times 2 times 5 would be 6 square root of 10 plus 5. Add together my integers, my final answer, 23 plus 6 root 10. Okay. All right. Let's go ahead and try some of these. So I've got a binomial squared. So that's a plus b squared. I'm going to, that is going to be equal to my first term squared plus 2ab plus b squared. Okay, so that's going to be square root of 3 squared plus 2, and I take each of those terms, multiply them together, plus square root of 6 squared. Okay, so now let's just go back and simplify. So this is going to be 3 plus 2 square root of 18 plus 6. Okay, well, 3 plus 6 right here, that's going to give us 9. Now this 18, I can go ahead and break that down into 9 times 2. So I can pull out the square root of 9. So then it becomes 2 times 3, which is 6 root 2. There we go. All right. So let's try B. This is the same thing. It's a binomial squared. Only thing is, instead of addition, we have subtraction. No big deal. So this is going to be my first term, 2 square root of 7 squared. So my first term squared, there's an x in there. Almost forgot it. Minus, I'm going to take 2 times each of those factors. And then 3. I don't put a negative 3. I'm already taking into account that negative right here with the minus sign. Then I'm going to always have plus as my second sign, and it's going to be my second term squared. Okay, so now let's simplify this. This is going to be 2 squared, which is 4, and then the square root of 7x squared is 7x minus 2 times 2, which is 4, times 3, which is 12. So it'd be 12 square root of 7x plus 9. So the only adjustment I want to make here is that right here, 4 times 7 is just going to give us 28x. So 28x minus 12 square root of 7x plus 9. There we go. All right, let us do C. So this is going to be a binomial squared again. So pause, try it, and then come back and check your work. All right, so you should have gotten 2x root 5 squared plus 2, which is part of the formula, and then I multiply each of those terms together, and then plus that last term squared. So that is going to give me 4x squared times 5 plus 2 times 2 is 4, okay? So 2 times 2 times 7 is going to be 28x root 5 plus 49. The only thing I want to adjust here is this first term, which should be a 20x squared. Everything else stays the same. Okay, let's go ahead to look at D. So for D, try it again. Pause the screen, do it, and come back. So what you should have done or recognized is that we have the same term as as the first term in each binomial, and then we also have the second term in each binomial that's the same. Then also notice that one is subtraction, one is addition. So these are conjugates. And conjugates are going to give you the difference of 2 squares. So this is going to be square root of 3 squared minus square root of 2 squared. Or 3 minus 2, which is 1. Love it. Okay. E. E's the same. These are conjugates. And they're going to give you the difference of 2 squares. So this one is going to be 2 root 5 squared minus root 7 squared. Don't forget to raise that 2 to the power of 2. So it'll be 4 times 5 minus 7, or 20 minus 7, which is going to be 13. Let's look at this last one, or this next one. So again, conjugates. So it's going to be root 3 squared minus x squared, or 3 minus x squared. That's all there is to it. And G freaks people out because they see all of these fractions, but that's not what I see. I see that the first term in each binomial is the same, and I also see that the second term is the same. So I know that these are conjugates. So I just take 1/2 square root of x squared minus. It's always minus because we're going to difference of 2 squares, not the sum. Okay, and then it's going to be 2/3 square root of y squared. Okay, so I have to take 1/2, raise it to the second power. Well, 1/2 times 1/2 is 1/4. So 1/4 x, because square root of x times square root of x is x. Now, minus 2/3 squared. I take the 2 and square it. 2 squared is 4. 3 squared is 9. The square root of y squared is y. That's my answer. All right. You guys, I can tell. I can feel it. You are grasping this. You are moving along. You are actually getting bored. That's a good thing. Okay? You've mastered that. Now, let us take it even a higher level. Okay? We're going to multiply radicals that have different indices. That just means the indexes are different. Wow, we haven't done anything like this. So let's pay attention here. If the bases are the same, here's what you're going to do. Okay, 1. Okay, these are if the bases the same. Convert to fractional exponents. Okay, so you change from a radical to a fractional exponent. Okay, step number 2, add the fractions. Okay, you probably will have to get a common denominator. That's okay. Then convert back to radical form. All right. What if the bases aren't the same? Okay. Then if the bases are different, here's what you do. Okay. Actually, we'll do this one in blue. I don't know. I like blue. Okay. So the bases are different. So 1, we start out the same. We convert to a rational exponent. Okay, number 2, find common denominators, create equivalent fractions. Okay. 3, the numerator becomes the exponents. So the numerator of your fraction, numerators, become your exponents. And then last, simplify and rewrite as a radical. Oopsie. There we go. All right, so let's go back to this. Well, actually, you can look at these in great detail. I'm going to go ahead and do some examples using these. So, first example, our bases. Well, first we're going to, let me back up a minute. Back up, start over. I am going to convert to fractional exponents. So our index for that first one, that first radical is a 2. So this is going to be a to the 1/2 times a to the 3/4. Okay. So now what I'm going to do is I'm going to add my fractions because I have a like base. Well, in order to do that, to add those fractions, I need common denominators. So I'm going to multiply the first one by 2/2. And that will allow me to add. So this is going to give me a to the 5/4. Now I can convert this back to a radical. Now, let me just kind of clue you in. When you have a fractional exponent that's a improper fraction, you are always going to be able to simplify that. Okay, just to kind of clue you in. All right, so this is going to give me, here's my radical sign. The 4 is my index, and then a to the 5th. But I'm going to rewrite that a to the 5th so that I have, using the multiplication property, so that I have an exponent equal to that index. So that is going to be a to the 4th, a to the 1st. So I can see here that my exponent and my index match, and so I can pull out a root. So this is going to be equal to a, that's my root, and then my 4th root of a to the 1st, I don't have to put that a to the 1st. There we go. That's now my answer. That's how I multiplied those. Let's go ahead and look at B. Okay, so with B, I've got here, I'm going to go ahead and first change these to fractional exponents. So I'm going to go ahead And this is going to be my base of 2x raised to the 1/5 times my base, actually I'm just going to put 2x raised to the 4/3. Okay, so I need to have a common denominator. It's going to be 15. So I multiply this first fraction by 3/3, the second one by 5/5. And so this is going to give me my base of 2x. I'm going to add 3 plus 20 to get 23 for my numerator over that common denominator of 15. So now I can put this in radical form. So my index is 15. My radicand is 2x, and then the exponent, I'm going to believe right underneath that radical, is 23. So my exponent is larger than my index. So I am going to look for a multiple of 15. Okay, well, that's not so hard to do. So that's going to give me, I've got here, pull this up, root 15. I've got my base of 2x. I'm going to raise it to the 15th. Now I can just take 23 minus 15, which gives me 8. So this first factor I can pull out, and it's going to have a root of 2x. So I pull out the 2x, and then I'm left with the 15th root of 2x raised to the 8th power. I can just leave my answer just like that. Okay, let's go ahead and look at C. So a C, oh my word. For C, both my radicand and my indexes, they're all different. It's okay, I can handle it. So the first thing I want to do is I want to change these to fractional exponents. So this first one is going to be 3 raised to the 1/3 times 4 raised to the 1/4. I am going to go ahead and I want to find a common denominator and create equivalent fractions. Okay, this is different than the last one because I don't have the same base, but that's okay. So I'm going to multiply this first fraction by 4/4, the second one by 3/3. Okay, so now I've got 3 raised to the 4/12 times 4 raised to the 3/12. Okay, so what I have here now is I have this common denominator, which is the same. So common denominator means same index. Okay. So then that means that the 4 and the 3 are going to be exponents underneath that radical sign, and they have the same index. So I can create my radical here, put the 12 as my index, and then it's 3 to the 4th times 4 to the 3rd. I'm just going to leave, those are going to start to be crazy numbers. I'm just going to leave it like that. Wow, that was fun. Let's do another one like that. Okay, I need to make some room here. Get rid of some of that other work. All right, so same thing. We start by creating fractional exponents. 8 raised to the 1/5 times 3 raised to the 1/4. I need to have common denominators. So I multiply the first fraction by 4/4, the second fraction by 5/5. Okay, so this is going to give me 8 to the 4 20th times 3 to the 5 20th. Okay, I can't add those because my bases 8 and 3 are not the same. But now I know that my indexes are going to be the same. Okay, so I can create a radical, put that 20 in as my index. Then this 4 becomes the exponent for 8. The 5 becomes the exponent for 3. So I have 8 to the 4th times 3 to the 5th. I'm not going to, the numbers are crazy large. We're just going to leave it like that. That is super cool. All right. Last thing, you should be patting yourself on the back as you worked through those. Those were tough. Okay? But you did it. You did it. Here's our last one. We're going to look at area. Area is super easy. Remember, area is simply length times width. That's all area is. So this is going to be 5 root x times root 121x. Okay. I can take that 121, that's just 11 squared. Okay. And so our area here is going to be 5 root x times 11 root x. So that is going to be 55. 11 times 5 is 55. Root x times root x is just x. There we go. That is what we call the exact area. We didn't do any rounding. Okay. All right. So for this next one, you can go ahead. I'm going to set it up for you. Area is equal to 3 plus root 5 times 7 minus root 5. And that, once you work it out, is going to give you 16 plus 4 root 5. Okay, you know what you need to do. Go get that homework done. Don't put it off.